Hello everyone, welcome to my YouTube channel. In this video, I am going to explain a topic: force exerted by a flowing fluid on a pipe bend. In short, it is also called as forces on pipe bend. So to find a force that is exerted by the fluid on a pipe bend or a bent pipe, the topic or the concept we use is the impulse momentum equation. So the impulse momentum equation is the combination of force and also the momentum. So here that force will be the resultant of the x and y direction force that is exerted by that fluid on a pipe bend. If we consider this bent pipe like this, as shown in the figure, this is in this shape as you see in the figure. So what happens is, at a bend, so say at point O, suppose this is point O. So here what is the force that is exerted by the flowing fluid? So fluid flows at some rate with some velocity v. So at this bent point O, there is a force along x direction and force along y direction. So that resultant force will be along another direction, making some angle theta or phi with x or y. So that resultant force is nothing but it is the force exerted by the flowing fluid on the bent pipe. That concept we are going to discuss in this video. So let me explain point to point. We can say that this is only the plan of a bent pipe. It is not the elevation, it is not the front view, it is the top view of a bent pipe. Please do remember this point. So you can see the number of forces that are acting on a pipe bend. They are very simple. The first one is V1, velocity of flow at section 1, and P1 is pressure intensity at section 1. And next we have A1 as area of cross section, and in the same manner V2, P2, A2 are the corresponding values of velocity, pressure and area at section 2 respectively. Next, before that, one more important point is, let Fx and Fy are the components of forces exerted by the flowing fluid on the bend in x and y directions. Fine. So what are these Fx and Fy? They are the forces exerted by the fluid on the pipe bend. Fine. So these are the forces that are exerted by fluid on pipe bend. So how many types of forces we can see in this diagram is, the first one is P1 A1. We know that for any type of engineering material, the first and basic thing is in a cross section area. So in that manner we have a cross section area A1 and A2 at the second outlet. So we can say that A1 and A2 are different. So we have pressure is equal to force by area. This is simple. Fluid statics, we have pressure is equal to force by area. So what happens to force? Then force is equal to pressure into area. So that P into A term is nothing but this is P1 A1. This is called as pressure force. Force, we have F is equal to P into A. That force is given as P1 and A1. Next we have that pressure force is due to the water. Fine, due to the water. And next we have pressure force at the second section. This is also due to water, but this pressure force, because it is in bent direction, we have to assume that it is towards the left side. Why? Because if we assume that it will be in the left side or downward direction or opposite to the other direction, then we can say that the flow is in equilibrium, or the flow can happen, otherwise the flow cannot be happened, right? So that is the reason we are having this along one direction and this along one direction. So these are the first forces we have. Next we have Fx and Fy. Next we have Fx and Fy. So what are these forces Fx and Fy? These are the forces that are exerted on the flowing fluid on the pipe bed, that are exerted by the flowing fluid on the pipe bed. Fine. And according to the Newton's third law, as there is an opposite reaction to every action, there is an opposite reaction. So this is Fx is nothing but this is the force exerted by fluid on pipe bed. So in that case, we have to be in a state that the same force Fx will be exerted by the pipe on the fluid. I am repeating it again. The force exerted by the flowing fluid on pipe is Fx, and the same force must be exerted by the pipe on the fluid. Okay, so in that case, that Fx can be considered as minus Fx while solving the problem. Fine. And next we have velocity at section 1. This is V1. I didn't write here. We have velocity here V1 and V2 here like this, as water flows from this direction to that direction. And resolve the components. We have V2 cos theta along horizontal direction and V2 sin theta along vertical direction. So, and for P2A2 we have this resolution: P2A2 sin theta along vertical downward and P2A2 cos theta along horizontal leftward with angle theta. So these are all the forces on pipe bend. And next comes the derivation part. The component of the force exerted by the bend on the fluid in x direction is minus Fx and in y direction minus Fy. So we have the momentum equation in x direction is given by net force in the direction of x. So net force, the total force, that is total force, is equal to rate of change of momentum in x direction. So according to the impulse momentum equation, the net force is nothing but the rate of change of momentum in x direction. So this is already discussed. So what is net force we have along x direction? So looking at the figure, so coming back to the figure, along x direction we have this kind of forces. So let's see what are the forces that are acting along the x-axis. The first force is P1A1 and the other force is Fx, but we have to consider as left side, just be in the recently I have discussed in this video. And we have one more along the left side, that is P2A2 cos theta. So from this, if I resolve it, you will get like this: P2A2 cos theta. So there are three forces that are acting along x direction. One is P1A1, one is Fx, and other is P2A2 cos theta. Fine. Next. So going back, so I am writing it as per like this: P1A1 minus P2A2 cos theta minus Fx is equal to mass per second into change of velocity. What is that? Mass into change of velocity, or dv or v, that is the impulse moment equation, right? So mass per second, we can write that mass per second as rho into q. Mass per second can be written as rho into q. So the units of rho into q as discussed here is, what is that? Kg per second. So that is mass per second. In that way we can consider that mass per second is nothing but rho into q for easy understanding. Otherwise, from the momentum equation, m into v is nothing but rho into q. Fine. And we have, so mass per second into change of velocity. Mass per second into change of velocity. So what is change of velocity? Final velocity in the direction of x minus initial velocity in the direction of x. So the final velocity is v2 cos theta, that we can see from the figure, and the initial velocity will be v1. So the Fx can be found as Fx is equal to P1A1 minus P2A2 cos theta minus rho q into v1 minus v2 cos theta. So similarly, in the momentum equation in y direction, so we can take these forces along y direction. There is no we have only p2a2 sine theta and fy, and this is as usual just we have discussed. So finally we get fy value also like this, rho 2 minus p2a2 sine theta minus rho q v2 sine theta. So the resultant forces acting on the bend is Fr is equal to under root of fx square plus fy square, and the angle made by the resultant force is given by the fy by fx. Tan theta is equal to fy by fx. Hope you understood it. If you have any queries, kindly post in the comment box. Thank you.